Welcome to the Explainer. Today, we're diving into what is arguably the greatest cosmic detective story of all time. Why are we seemingly completely alone in the universe? Seriously, I'm thrilled you're here, because the stuff we're about to unpack will absolutely change the way you look at the night sky.
So let's start where this whole cold case began. The year is 1950. The brilliant physicist Enrico Fermi, the guy who built the very first nuclear reactor, is having a casual lunch at Los Alamos. They're joking around about a cartoon of aliens stealing trash cans. And out of nowhere, Fermi just drops this simple, incredibly profound question. Where is everybody?
To figure out where everybody actually is, we're going to follow four main clues today. First, the grand cosmic silence. Then, equations of the unknown. Next up, the great filter threat. And finally, we'll explore dark forests and cosmic zoos. All right, clue number 1, the grand cosmic silence. Okay, try to wrap your head around this number, 70 sextillion. That's a 70 with 21 zeros after it, and it's our best estimate for the number of stars in the visible universe. Just our Milky Way galaxy alone has hundreds of billions of them. And thanks to what scientists call the mediocrity principle, we know Earth isn't some uniquely magical place. It's just a regular planet orbiting a totally average star. So run the stats. With billions of years and billions of planets, the universe should literally be swarming with intelligent life. But here is the massive paradox. We've got these colossal radio telescopes constantly listening to the void. And what do we hear? Nothing. Just deafening silence. The universe has been around for almost 14 billion years. Even crawling at a snail's pace, a sufficiently advanced civilization could have easily colonized the entire galaxy in just 5 to 50 million years. Yet we see no probes, no radio chatter, no megastructures. Zero. Which brings us to our second section, equations of the unknown. For decades, the go-to tool for trying to solve this was Frank Drake's 1961 equation. It basically tried to calculate how many communicating civilizations were out there by looking at star formation, habitable planets, and the odds of life getting smart enough to use radio. It's why we actually beamed messages like the famous Arecibo broadcast out into the dark, hoping someone would pick up the phone. But there was a massive catch. Most of those variables were purely guesswork because, well, we only have exactly one example of life in the universe to study: us. Because of all that biological guesswork, modern thinkers like John Gertz argue that it's time to totally rethink our approach. Instead of agonizing over how many planets might magically brew up biological life that eventually builds a radio, Gertz says we need to focus strictly on what alien technology we can actually detect right now.
He proposes the Gertz factor. It strips everything down to one single metric. What fraction of technological life out there is actually detectable? We're not just scanning for biology or a polite radio transmission anymore. We're hunting for technosignatures. Think massive alien engineering, the glow of artificial city lights on an exoplanet, rogue AI probes hanging out in our solar system, or even Dyson spheres. Those colossal structures built entirely around a star to siphon its energy. It completely changes the game from passively listening to actively hunting for footprints.
Okay, moving to section 3, the great filter threat.
So if we can't find these footprints, why not? To explain this, economist Robin Hanson tried to map out the evolutionary path from dead matter all the way to a spacefaring empire, which boils down to 5 massive evolutionary leaps. Hanson's point was brilliant but pretty chilling. Since we don't see massive galactic empires, at least one of these steps must be almost impossibly hard to cross. He called this roadblock the Great Filter.
The implications of this are, quite frankly, terrifying. It all boils down to this. Is the Great Filter behind us, or is it waiting for us? Did we already pass it? Maybe. Jumping from single-celled organisms to complex life was the impossible lottery, and we just got incredibly lucky. Or, and this is the scary part, does every advanced civilization inevitably hit a wall they can't get over? A filter like nuclear annihilation, climate collapse, or catastrophic resource exhaustion that destroys them before they can leave their homeworld.
This theory completely flips our intuition on its head. We spend billions sending rovers to Mars looking for life, right? But finding complex alien fossils right next door, that would actually be the absolute worst possible news for humanity. Think about it. If life sparked up totally independently on 2 neighboring planets in the exact same solar system, it proves that those early biological steps are practically inevitable. They're super common. And if life is common, the universe should be packed with hyper-advanced intelligence. But again, it's totally silent. That would mean whatever wipes everyone out, the great filter, is almost certainly still ahead of us. It's waiting in our future to take us out before we can spread to the stars. So yeah, weirdly enough, a barren, dead Mars is actually our best-case scenario.
Now for our final section, dark forests and cosmic zoos.
What if civilizations aren't being wiped out? What if they're just hiding? The sci-fi author Liu Cixin laid out these brilliant, almost sociopathic axioms of cosmic sociology. It goes like this. Survival is the ultimate goal. Civilizations will naturally want to expand, but the universe has a finite amount of matter and resources. So logically, any other intelligent life you detect out there is a direct, inevitable threat to your own survival.
This leads us to the dark forest hypothesis. It argues that broadcasting our location to the stars isn't a friendly wave, it's a fatal mistake. The universe isn't empty. It's a pitch-black forest filled with terrified, heavily armed hunters. The second someone strikes a match and says, "Hey, I'm here," the other hunters have to instantly shoot into the dark to eliminate the potential threat. In this reality, the silence of the cosmos isn't an absence of life. It's the sound of everyone holding their breath in the dark.
But hey, let's end on a slightly less horrifying note with the zoo hypothesis. What if a vastly superior, hegemonic alien power is basically enforcing a cosmic quarantine around Earth? In this scenario, super-intelligent life absolutely exists, but they're treating us like an exhibit in a nature reserve. They might be quietly watching us from behind a one-way mirror, waiting to see if we manage to stop destroying ourselves and mature as a species before they finally make first contact and let us into the galactic club.
So we've looked at this staggering math, the looming threat of a great filter, and the truly wild ideas of dark forests and cosmic zoos. As you step outside and look up at the night sky tonight, I want to leave you with this. Is the universe just a massive, empty graveyard of civilizations that couldn't make it? Is everyone out there hiding in pure terror? Or are they just quietly watching us right now, waiting to see what we do next? Thanks so much for joining me for this explainer. Keep asking those big questions, and I'll catch you next time.